Hi, everybody. Is that working? Okay. Let's see if we get a little. Good afternoon, out there in virtual land, wherever you are. If it's evening, morning, one thing I've learned doing this work is you get people all over the world, and the times are just crazy. Since someone asked just a couple minutes ago, Regis University's in Denver, Colorado. I actually live closer to University of Boulder outside at 8,900 feet. So our little town has this saying, we're higher than you are. So it definitely down here flatland. Doesn't matter. It's the humidity. It's really tough. The other thing is I changed some things already. So the slides, we're going to wing it as we go. Generally brief introductions, CSG-Ed. I'll say what that is, and then we'll look at some, get into the activities. Since we already did, I wasn't sure on the brief introductions. The one thing I do want to hear with the introductions to extend it is organizations. How many are sort of small private liberal colleges? Good. Big research institutions? I know we have an industry, then what's left between the R1s and the small liberal colleges? Sort of medium? Yeah, okay, yeah, that's an interesting classification then. So I did think they always told us, introduce a little bit about yourself so you know where I'm coming from. The way I think about it, previous lives, I'm a computer scientist and education-wise. Lock Haven was the smallest state college in Pennsylvania at the time. I did my master's at Rutgers University. It was like, welcome to the big world. And did my PhD at CU Boulder. And I started my career in industry. I was lucky as a kid in a candy shop to get a job at Bell Laboratories in the Knowledge Systems Research Department doing AI research. So it was like really kind of cool. I got headhunted out to Colorado and did some startup stuff. I've done production level systems. I sometimes kid. I've worked from the smallest company in the world. AT&T was the biggest company in the world at the time. I've worked on projects that are small, went nowhere. I've worked on projects that 5,000 people used out. I'm embarrassed because now Google has stuff that, billions of people use. So that's kind of a cool thing. Always wanted to be an academic. So I did a switch and opportunity became 22 years ago, Regis University in computer science. And I've been teaching ever since, doing the kind of what we all, those of us in academia, all but one of us, right? You jump up, you jump up, you jump up. And then eventually your life, sorry, I can't say that word, goes bad when somebody says, be the chair. So the next part that's kind of current too is service. To give you a little bit, I am sitting right now on the CS 22. It'll be 23, I'm told. Carl's done work like this. It's a curricular committee. I would tell everybody get involved. It is the coolest thing in the world, and it's also the biggest headache in the world. But you do learn a lot. That setting the curriculum for the next decade. A little bit of a joke there, right? But in computer science, right? It won't meet again for a decade. So we're trying to get things right. Of course, in the 2 years we've been meeting, especially because of the AI world and what's happening, big data, it's changing probably faster than you can set. Any type of curriculum. I'm also on the executive board of COPE, the Committee for Professional Ethics. There's a lot of overlap with social good there in interesting ways. And what I'm really here today is I'm on the executive board for SIGCAS, Special Interest Group, Computers and Society, and how that fits in. There's the mission statement in the beginning. You guys can read it real quickly. SIGCAS is in its 52nd year, so it actually goes pretty far back. We publish it's officially a newsletter because ACM is very particular about what constitute a magazine, but Computers and Society, I'm the chief editor right at this moment. But the cool thing about that is it won't get you tenure, but you can publish opinions on what's happening from computers and society, ethical issues, impacts. We would treat all computing, not just computer science, and certainly big data science, AI stuff. Some people really know how to take advantage of it. It's really good for your students too. We will publish students things because it's not, it's reviewed, but it's not a peer reviewed type journal. We're not trying to do that. It covers a lot of areas, but there are the three big ones that are sort of umbrella, meaning people found their home. Compass, they're focus on computing sustainability, computing systems. HFOS, which is really goes back, but open humanitarian focused open source. A good example of that, and I don't know if I have a slide on this coming up tomorrow, but one of the things that happened there is you can have a student do a summer project where they're contributing to open source code focused on the social good. If say they can't get an internship, that community is very welcoming. Where I found a home after working in isolation for years, so to speak, in academia, was in the CSG, Computing for the Social Good and Education movement. And I have a lot more to say about that, but the umbrella sits under there. You get free, ACM provides us a website, stuff like that. So there's some reasons we sit under computing the SIGCAS. So here's a definition. It was coined by a fellow, Mikey Goldweber. He's going to come up a lot. He's at Xavier University in Cincinnati. So again, the focus on education from Mikey would be the first one. I would tend to agree with him. The group here probably falls under this umbrella. Nobody's trying to earn turf. What we're trying to do is grow community and faculty that are focused on the social good. So I've been calling this, I've been kidding Carl a little bit. It's okay, Carl. This is a bit of a flip talk. We're going to do, I have a plenary talk tomorrow. There, I'm going to go into a lot more of sort of what we know out of this community and what's happened over the last 30 years. So today's workshop, we're going to focus on the incorporate any educational activity. So what am I really saying to you? Today, we've already had some motivation. You're here probably for these reasons, right? But today we're just going to assume what we're doing is good. Tomorrow, I'll throw some in. I said I'll take a biology shot. For example, we know things, it's not going to help biology, but we know that if you do an integrated biology project in a CS1 course, it increases retention for that student in the curriculum. There's things we know of that nature. It was already mentioned. We know that a social good helps with retention of women. And I'm going to mention a lot of times in the first courses. So if your first course is not a traditional, for example, CS1 course, and obviously for the business people in economics, that's probably not true. We know there's an inverse correlation with computer science and women in technology. There's data out there like that. And one way you can begin to break down those barriers and for underrepresented minorities is computing for the social good. And one of the things you're going to hear me like emphasize a lot, again, I'll get into this, of that first course. If you do your first course the way academics have historically done it and still do it, unfortunately, that can be a turnoff and you can lose that student today. So not only do we have recruitment problems that we can to broaden participation, which is one of the goals of the data science curriculum, we know that these activities do that. So there's been a lot of research out in that area. Anecdotally, it fits that way too. But since we're starting with a workshop today, we're gonna try to go right into the workshop part, and I'll leave some of that stuff for tomorrow. So how do we do this? And there's not going to be anything completely new, insightful that you maybe hadn't thought about that you don't already do. Part of growing the community is contribute. There's certainly overlap with the previous talk that we just heard. Already I've told you on some things. Another one that pops into my mind is tenure. One thing that's hurting computing for the social good historically is those type of activities don't get you tenure. We just got a brand new journal out in ACM on focused on on the social good. So that begins to help us as we integrate these activities in. So what's we've published some work where we've done a taxonomy. I'm not sure I totally believe in this taxonomy, but you have to get what the motivation was. So at level 1, you have the low-hanging fruit. Okay, you redefine an existing activity with a CSG-Ed, right? Computing social good education narrative. So what I mean by understanding that is getting at this, how easy this is to do. I'm going to be the first one to also admit, if you give me an example of how difficult it is to do this, yes. Michelle Trim's a big contributor to CAS, and she was at a conference within the last 2 or 3 years, if my memory serves me right, and we started talking about this, and somebody raised their hand and basically said, no, I just teach the technology. This whole idea is terrible. And that's what we're trying to get out of. So that's barriers that can occur. So in this case, we're going to look directly at activities. So I have some examples before to help get us started. And at level 1, here is a classic one. I took this from my favorite algorithms book, Levitin, 2007. I have some examples to show you. They're all the same. You're given this problem on the left. Okay, we got a fully connected graph. On the right, we have a solution. The solution's a minimal spanning tree. In this case, the example occurs within the context of Kruskal's algorithm. And I guess, yeah, you can learn right from this. We all have. It's going back to the 60s, things like this. But here's how we might change this one to a level 1 activity. So remember, level 1, what we're focused on is, here's an existing thing. It's in a textbook. I have used this example in my courses. Okay, slightly different. Consider a village. I know you can read this, but God, you got N farms. We got a single water reserve. Each farm needs to be connected. They need water, right? Directly or indirectly. You want to construct this from a business purpose to save some money, right? So we can, you're giving a graph, right? A table to the students. It's a fully connected graph. It's what you just saw in the previous slide. We can optionally ask the students to reduce the complexity of this graph. But ultimately, since they're learning the Kruskal's algorithm at this point, what they're really doing is a minimum spanning tree. See, what I'd like to convey to you at this point is we really don't need to say any more about level 1. I will, but there it is. All right, we just turned this from just a plain old blow, bunch of numbers, bunch of boring stuff for students, to a computing for the social good problem that actually has some implications. And again, as was said earlier, it might attract a different type of student. I often do this a lot. I get excited up here. My wife's a physician. There's no doubt when people talk to her, other than maybe sometimes telling her problems, they know she's helping humanity. I say I'm a computer scientist, and they kind of go, eh. All right, even though an echocardiogram machine, all right, surgery that's computer assisted, you know, all the things that this community sort of knows. So virtually every activity can be an assignment, can be wrapped, right, in some type of social good. I'll admit it as we move on a little bit. Yeah, sure, bigger data gets a little bit harder. I would tend to agree with the observation earlier. It's hard to construct and move towards a problem, but there's ways around that too. So another example, don't simply loop through numbers, sort of list the numbers. So this slide, I did it yesterday, made these up real fast. You got to sort, compare, find the average, right? Again, a very early CS1 type activity programming. We're going to go through the array. You got all your classic learning outcomes. It's all there. And we're going to do the average, the array on the right. I tried to pick them. I didn't actually do it. I think it's a delta of 6 difference. What do? Turns out 6 difference, I worked this one backwards, is the millimeters, your blood pressure being your diastolic, that's lowered from losartan. Where did this example come from? I'm on losartan for hypertension. It lowers my blood pressure. So I just happened to be, coming here and thought, well, can I make one up to try to demonstrate again how easy this is? Again, personal experience. We're working some now. I happen to think a design pattern language approach, and we're going to talk about this a little bit later, might be the way to go. But one design pattern that I just used is use your own personal experience. Where do these things come up with? How do you come up with a computing social good activity? I have some more examples coming up. Now, as an aside, since this was data for good in education, I went and looked at the curriculum. I was telling Carl earlier, a great curriculum. If you guys don't, it took me a number of years in education before I realized people spend a lot of work on curriculum standards. You ought to take a look at them because at least you know what you're ignoring. At the point when they are aligned with what you want, like computing for the social good, then you can use that to your advantage. But in there, there is the PDA knowledge area. Programming data structures, algorithms. If you're pursuing the data science curriculum, following sort of those guidelines from knowledge areas, then essentially all of the CSG-Ed research and work that's done previously applies because there's the overlap of sort of traditional computer science. Again, not telling you what to do, not trying to, but there are some resources that are sort of out there. But then I thought, okay, well, I'm not going to bore you to death. Here's something, honestly, I would never do in a CS1 course, but here's a linear regression example. I pulled this out of, I guess, Skit-Learn, the book, Hands-on Machine Learning, okay? And typical thing you'll see in a book, right? So we got a bunch of data points. I believe these were actually generated as a Gaussian with mean, distribution. So the question here is a little Gedanken experiment, not a workshop one, but how do we make this a CSG-Ed example? Okay, just a second or two. Why don't we just relabel the axis, right? Here's the average years of life lost. Here's packs of cigarettes smoked per day. Turns out there's data out there that pretty much is linear correlated. It turns out, interesting enough, it's hard to find complete linear correlated data. They almost always go nonlinear at some point in time. But see, all I did is relabel it, okay? I'll plug my daughter at some point. She is working on a master's thesis. She's a lawyer, sociology, psychology, philosophy major, or whatever, by education. But she's looking at like, how should as software engineers we define good? We're going to ignore this at some point, but I thought there are some good observations too. So if it's not cigarette, if you're a personal smoker in life and you don't want to go after it, then label it something else, right? Okay, that's simple. So remember what I'm trying to do here. Level one, we're trying to get you at how easy it is just to do this. Is over 1,000 universities use the Russell Nervik textbook, AI Introduction, if you guys use it. Here's the traditional example from that book, and is in a lot of data science stuff, because somebody out in California did housing versus square feet house. CSG borderline for me, but it's okay if this is what your thing's doing. And notice it's still better, my claim, than that first one, right? Where you just have X, Y. We added something that shows. Again, it's basically a linear one. This one's not too surprising that prices go up as square foot go up. Here's another one from the same textbook. Again, these are all in showing linear regression is at the topic at this point in the machine learning part of the textbook. You got earthquakes, you got nuclear explosions, and they sort of go on and try to show you a little bit of how these are difficult to tell from each other. My textbooks on machine learning when I studied it are ancient, but I just pulled them off my shelf as I was putting slides together. They're just sitting there. And the point of these books is not to go after any individual author, any book. Every one of these sources right here have just unlabeled data. Okay, and they could all achieve the same thing with a little easy social good focus. Again, labeling the axis in some way. If you wanted something completely new, I did the Coursera linear regression courses are a bit of a mix, but the most popular course is just, again, unlabeled data. I don't think it's too complicated to label the axis. That's the point we're making. So again, I talked a little bit, I'll come in and out. It's work in progress of whether design patterns, we're gonna do this, going to create this language. Show of hands, everybody knows kind of design patterns at some level or not? Oh, okay. So I'll say a little bit there. They come out of the work. I may have this slide somewhere of Christopher Alexander in architecture buildings and his group of people. And the Gang of Four, they're called, picked this up of design patterns and object-oriented programming. I love the observational thing. So a little observational comment, it kind of gets lost in programming and software engineering a little bit, in my humble opinion, as a language. And I can say a little bit more about it, but for those of you who know the design patterns already, you know, if I do something like singleton, mediator, things like that, facade, you know, sure, if you're focused on that area, it really makes a lot of sense once you understand it. But at Christopher Alexander's level, it tends to make a lot more sense. We're gonna construct a cathedral. It's going to be south facing. It's going to have a little atrium public area, things of that nature. The way he defines it is you have a problem and you're providing a solution to a problem, but the solution changes in a million ways. Think about what I just said. There's a chapel, right? We got a chapel on the Regis. Regis is a Jesuit institution. It doesn't look anything like this. On the other hand, it's a lot like this, right? Do we have some type of stained glass? Yeah, but they're not panels in the front. Ours don't have, if there's any physicists here, we don't have Schrodinger's wave equation, you know, in the stained glass. So you get this idea of how the patterns sort of shift around a little bit. Point for those who already did design patterns, when you read Alexander's work and you see what he said, and he lists these patterns, you can start imagining, yeah, I know what this place is going to look like. My claim for software is, nah, you don't really know what it's like. You know, if we're focused on one thing, the United States government's a singleton, sure, fine, that makes sense. But if I just say singleton, meteor, this, that, it gets a little lost. So the patterns can be arranged. So what are creational patterns? I already showed you one, whether it's patterns or they're just text written. Personal experience. The news media. Okay, if you're looking for computing social good, I mean, I'm pretty sure I got to take out my phone. The New York Times app will probably have something today on how bad AI is at the moment. So, and you can begin to use that. They'll probably have something on how good AI is at the moment too. So you can be sort of inspiration is the word I'm looking for. Now, for big data science people, I imagine open data sets. Okay, you know about this. For typical computer science faculty, this is a big deal. Right. Tomorrow's talk, I have a little bit of, like I said, in the motivational side, but almost every city in the United States and some throughout the world have certain laws of making data public. And we'll talk a little bit about that. You can go after open data sets and then begin to solve problems based on open data. One year we did this in CC in Portland. Portland has an open tree database, right? Where every tree is in the city, and you can do carbon footprints. Mikey would give you one. Cincinnati has police arrest. I'm pretty sure. I was looking at Chicago data. I was going to do it, and then I have to admit, as easy I'm telling you it is. The moment you go to big data, it started getting a little harder. But they do have police reports in Chicago. Everything except for I think it's murders. You can go out, get the data right now, and you can have your students do that. So again, go back to an early introductory course, right? So I'm going to take it away from the data science part, I said, but why not loop through that data to find something versus looping through a bunch of numbers. Now it's real to the students. There's tons of examples like if you're going to route ambulances, can you find food deserts? It just goes on and on and on. Sorry, there's a slide. I should have flipped to this side. And some of this was just the links aren't important. Per se, it's just where we've given various workshops, and it's where 6C was, where we gave one of the workshops. So you got the Providence data, got Mikey's Cincinnati data. It does take some working. I did a social good project that was street data available in Denver. And what I was trying to get at for the students was shortest path routing isn't necessarily the best way to route traffic data, right? You got a big freeway next to you in Denver. They've been working on this for years, and they take you off the highway. Well, I don't want that data going through. I'm sorry. I don't want those cars, that data, right, going through my neighborhood. Right, there's a social good focus, right? You need to have students think about these things, would be the claim. One thing with the Denver street data, it was so dirty and unusable that it was really hard to process that. But then we turned that into an experience for the students of cleaning up the data. This was more capstone type course. Again, just another example you can iterate, as I said, over. Hopefully you got the idea now where we're going of open data. You can have the students just open this open data file and process it. They're doing, again, we're level 1. So we're still doing the same assignments we ever did. All we did is change, in some sense, all we did is change the data. Portland open one. This was some real data from the line. I didn't know where to put it in, but because it does come from an open data set that's out there, I threw it after the open data, but we're right back to linear regression of poverty versus morbidity. So got a lot of data points there. So now it's a workshop, as Carl keeps saying. And what we'd like to do is small groups. These tables are good. The only problem I can see, we normally do 3 to 4, but you don't have to worry too much your size. Here's the problem as I say it. It's not so much you interacting, but we want to have a readout when we're done. What's the most interesting one you came up with? What were your discussions like? And that's where it gets a little bit hard as we have numerous groups, but I would sort of stick together. Table 2 would be fine. But what we're going to try to do is think up and redefine an existing activity that you could use in your classes right now. You're free. This is your workshop, not mine. You're free to go wherever you want. The only thing I'm asking, and I purposefully didn't tell you the other levels, but the real key at this point is something that you already do, but it's not socially good focused. How would you use it in your classroom to put a social good focus on it? Okay, does that make sense what we're trying to do? And this is a takeaway. Like I said already, if this is your first class, you don't have to focus. You can focus on your capstone. But if this is your first class, be it wherever in your curriculum, you may have just had increased retention. And if the word gets out there, you might have increased recruitment. I'm going to read the room. I was thinking 15, 20 minutes and then 10 minutes report back. We've done these in the past. Please don't finish in 30 seconds because I won't be able to. Well, I'm a professor. I can fill anytime you want. But the idea, yeah, thank you. and the thing is, I'll try to read the room when we're running out of energy a little bit and then bring us back together. Okay, everybody, I'm going to try to bring you back. Thanks. Get that last comment in. We're going to bring everybody back. So I'd like to continue by going around table to table. Give what you think your best example is. Keep in mind, it's your time, but it's time constraining. So try to, let's keep it to a minute, and that, then 10 minutes we'll get it, through. So see if you can rip it out real fast. You don't have to go, but here's where you can share with the group. And again, somebody, as I'm telling you what somebody at this table may present an activity that somebody at this table can use tomorrow. Well, sorry, not tomorrow. You're all going to be here tomorrow. How about Monday? All right. I guess go to my right side. We'll just do this table first.
Good afternoon, everyone. So our group talked about many examples. I can start my name, I guess. Amy Abouakwame, Howard University. The course I teach is an Intro to Python course for non-STEM students. So they don't have a STEM background, don't have computational thinking in mind. And what I hope to redo moving forward is allow them to start with owning and kind of collecting their own data. So when we talk about, having iWatch or Apple Watch and collecting your steps, then comparing that maybe to how much they sleep. And over time, you can see maybe if it's linear, and hopefully they can see the good in data for themselves, then also looking at other people's data for good as well. Stop there.
Great. Yes, thank you. Yeah, next table, just pass it. Yeah.
Carly, sure.
Do we want them at the podium because then they're on the camera?
Let's have them come to the podium.
Yeah, bring it up to the podium then, please, because there are people I know, well, it's your, Andy wore her 15 minutes of fame,
I did the work too, because I'm excited about this too. So we talked about two different kind of ideas that I'll share. One was in machine learning and clustering algorithms. And we were talking about how so many of them just use sort of really generic data or use the iris data. And one of the ideas that we sort of talked about was going into Gapminder and trying to explore the data set a little bit in Gapminder and say, can we find some clear data sets in Gapminder with that? Gapminder, if you don't know, is a really nice set of fairly socially integrated socially relevant data sets. And it's a very good visualization tool, which then might allow us to find a data set that we could assign to the students to practice clustering on. The other one we talked about was in a parallel computing class and talking about locking and synchronization mechanisms, which there is everywhere and everywhere else. There is the example of a shared bank account, and that is clearly not as socially responsible or relevant. And so we kind of came up with two different ideas for replacing that with sort of a socially good perspective. One was talking about the shared resource of water in a water reservoir. So in particular, this is relevant to you guys. We were thinking about the Colorado River and how the fact that there just isn't enough water for all the water demands in the Colorado River water basin. And so thinking about whether that could be turned into a locking and synchronization problem about access. The other thing that we all got very animate about from those of us who have lived in Baltimore and DC was traffic grids and the fact that people can't respect the laws of not entering the traffic intersection when it's green, but you can't get through the intersection, and how there is a shared synchronization resource of the intersection that then causes problems when you can't synchronize it properly.
That's great. Yeah. Our next table, please. Yeah. That's a great example. What did I just tell you guys? I told Carl earlier, I have a faculty member who's leaving. We're a small faculty. I may, just because I'm the chair, have to teach operating systems. I really don't know anything about it, but I do know there's locking, and I do know how to do social good now.
Hi there. So our group had a couple of great ideas. One of them, it was in response to the idea that one of our educators at the table had to find a data set for an honor student and went through quite a bit of work to do that. So some of the places we thought we might look to next time that might happen would be using comic book data that's been used in the past. That might be of interest to students. Also, the idea of doing a icebreaker at the beginning of the semester to find out what students are interested in order to choose topics and find data sets that way. And then another idea was to perhaps use on-campus examples for data. Perhaps that might come from your facilities department or your institutional research department, perhaps to inspire students to get more involved and think about more about their everyday built environment, perhaps utility data or greenhouse gas emissions or things like that. Thank you.
Alrighty, hi everybody. So one of the things that we were talking about at our table is I teach a database concepts course. And so we teach students how to kind of build databases with SQL and clean data and do all of this kind of stuff. And so I've done a little bit of kind of using open data sets and kind of working on kind of massive data sets for social good in the past. But one thing that we were talking about is that context of the assignment definitely matters. And so, for example, last semester, I gave an exam in kind of, can you build a query? And the data set that I used had to do with like drug overdose deaths and things like that. So very kind of core principles that I wanted students to reflect on. Zero of them care about that because it's an exam. They want to know that I have done the query correctly. I have written the code that I wanted to, and they're not reflecting on it in the right way. And so one of the things that we were talking about is kind of making sure that the assignments that we're kind of using these data sets for actually enable students to reflect on that. Yeah.
Yeah, absolutely. Excellent. I guess we'll go here next. Yeah. And again, we're trying, I get it. We're trying to stay positive. We all run into the barriers and students and engagement. So not a comment on us, but I'm purposefully like ignoring the problems, right? It's like, let's, yeah, rah, rah.
Hello, everyone. So we talked about how to get students to be interested in the activity. So the first thing that we suggested was to have them pick their topic, right? And a topic that is relevant to them. So we came up with looking at the access of water in respect to the neighborhood. And then also we came up with the question of looking at the impact of social media and health. And then the last one was looking at what was it? Trying to make a data sets available to students, like open source data sets. And then the last one that we brought up was looking at the impact of what was it? Is that? Of carbon usage and the energy, right? Energy. But I think that the issue we had was how we all define the concept of social good. Because if we don't have the same definition, then if I come from the field of sociology and he's in the finance, right? It's going to be a different concept. So how do we all have what? The same definition of what is social good? What is it?
We do a lot of that reminds me of, and then I'll make it a little bit. I was talking to JD in the break, and this is what you remind me of. I've had the pleasure, you'll see tomorrow, some papers just self-serving to work with my daughter. And again, her undergraduate was a philosophy, psychology dual major. She went to law school. She practiced, she wrote some pivotal papers for the ACLU, but then she practiced family law, got it's discouraging. Doing a career switch into a software engineering degree has been very active in the computing social good ed area. All right, here's the point of all that. I was give you enough context of not so much that I want her to come work for Regis. I couldn't hire her. She's exactly what we need, right? This to bringing the different perspectives. I mean, the first for all of us who are computer people, she gives me forever. And she's in her 30s, so it's not a young lady. Well, sorry, young by my standards. Why did you ever name that thing this? Right. So that's what you reminded me of. But I would also say one of these lessons learned, the more you can interact with other faculty members, with other people who just are trained, educated differently, they bring these wonderful other perspectives. It's easy to find the core shared values that you're doing, but things that as a computer scientist, I would never have thought of, it could be just me, but my guess, I see some of you shaking your head, right? If you can do this cross-disciplinary, so it's absolutely fantastic. I'd say we get our next table right here. I don't want to, I told you I could pontificate forever, but please.
Hi, so we discussed a couple of things that, some data sets. I also got to know about a new data set that I didn't know that from my colleague. It's called the IPMS data for social good economics. So how this came to our head was like he was talking about, wanted to mention that, the payday loans or the mortgage, like vehicles, leasing mortgages are related, instead of saying, this is how it should be done, and you use that data set to teach students. And the other one we discussed is which I use it to do the cluster analysis work. I tell my students to go to the UN data repository and World Bank data, get the GDP data, GDP per capita. Then I said, run the cluster analysis. If you use it unsupervised learning technique, you will definitely see at least 3 clusters getting together. So then, and I tell them, go to the World Health Organization data repository and take a look at the malaria data, right? So run the analysis, cluster analysis. Again, you will see some countries ended up in certain clusters. What is the difference? Certain, the GDP, when that comes in, the countries like United States, Canada, Australia, the European countries ended up in one cluster, Sub-Saharan Africa, then Polynesia, then ended up in another cluster. There you can see that 3 different clusters. Again, then when you switch to the other data set, the malaria, then you see predominantly Sub-Saharan Africa and Southeast Asia. Then you look at the differences, you will see in different classes. So that kind of a social good aspect. And instead of saying, hey, you know what, do this is k-means, and instead of throwing at the unsupervised learning technique, because I can put them to sleep with my presentation slides. We all know, right? So that's the strategy I use. Then she was talking about using census data as well. So that's what we were talking about.
Excellent. Next table. I don't want to comment on that. That one's just so great. All right. I guess we'll go, go here. But I love that we try to encourage our students. They're the solutions to the world's problems. And we talked about this too. It's hard for you guys. I don't mind, right? The world's in trouble. My students, you don't want to just constantly blast them with that, right? And judgments, right? But we want them to think about it. And there's these great, they are the future, right? So to get them to think about this, the clustering data is just incredible. Please.
Okay, so on our table, we have a colleague who teaches computer networks. And each semester, he asks students to collect the bandwidth about upload and download of the internet service provider at their home, restaurants they visit, or their friend's place, or, even shopping malls and all. And the idea is, of course, you can have a lot of data, but students can learn the business side of it. Because, for example, if there's a monopoly, right, they will charge more. But if they are in the competition for the same bandwidth, upload and download, the charges would be different. So they can do some business analytics, for example, and also you can learn different demographics. The rates would be different even if the download and upload speeds are the same.
Thank you. Thank you. Two more tables for those, and if JD's around, did we get in online?
I think we had three-ish ideas. One, actually, given the departments we're in, our context, the type of students we're teaching, a lot of our, for me, for example, teaching entirely graduate students in education, everything's impliedly related to social good. So one of the ideas we cooked up was, if you're in a pinch, maybe it's the end of the semester and you're like, criminy, I forgot social good. Have students do a retrospective, revisit a previous project from earlier in the semester and have students do a retrospective, have them invent how it might connect with the social good. I know, right? I love, that's not my idea. That's one of your Trinity colleagues invented that one. Yeah, do the retrospective. The other thing we talked about was, if you're going to relabel axes, relabel Anscombe's quartet or data loosely based on Anscombe's quartet. Great. I think that's a great idea to generate fictional data in general, just relabel. Oh, if you don't know Anscombe's quartet, maybe we can pull up. Wikipedia has a great article on Anscombe's quartet, and it's basically 4 completely different scatter plots where the X and the Y all have the same mean. Yeah. Dinosaurus is based on Anscombe's quartet. Yep. And then what was the third? I guess maybe that's it. I guess I know there's another one, but those 2 will get you started.
Excellent. Excellent. Yeah. We got one more table too. I love that one. The first thing I wrote, and I didn't tell you, I'm no expert, all right, but you do a lot of knowledge. And I will say, I don't think I've ever seen out in the literature, make them revisit one, right? Don't go out. Okay, you did this. Now could you? Right.
Yeah, it's the biologist again. I am grateful that I came from a table with a very diverse group of people. We had someone from geology, we had someone from computer science, and well, by now you all know me. One thing that we talked about was that student level mattered. So our computer scientist was very interested in teaching things like version control using Git or GitHub, which is something I would love for my biologists to do, but they cannot unzip a file. So we have to not only approach good data science in terms of what we want the student to take away from it, but also where the student is in their education. And frankly, my biologists are going to be lucky if they ever learn how to unzip a file. But that doesn't mean I can't start them somewhere. So that's a lot of what we discussed.
Yeah, that's great. I have a slide for tomorrow's talk too. Essentially meeting the students where they are. I mean, social values, their perspective on life is formed by the time we tend to get them. I'm not a sociologist. I don't want to go beyond my limits. I do know the Jesuits and the Regis mission is the sort of how ought we to act. So we're trying to just make them think about these things, give them the tools to consider it, right? Of course, I assume I'm telling you things you know, but again, there's data out there. So we're playing it. Let me see do a quick time check. Yep, thanks. Playing this by ear a little bit, as we say. So level 2. Level 2 is explicitly address a social good problem, though in a simplified form. I don't think these are clear distinctions, just so you know. But again, the difference in the level 1 and the level 2, at least conceptually, is again, 1, you're taking something that just exists and you're transforming it. Level 2 has the same feel, but now you're purposefully going after a problem for the social good. Here's an example of one that I found out online. It's Greenfoot data. It was COVID. It was created. It's a finite state machine course. So in some sense now, depending whether that's in your curriculum or where it appears in your curriculum, for us, it's in a computation theory course and a principles of programming language course, again, within a straight CS degree. And you can basically, it's kind of cool to watch this thing run, but you got these cities and they feed into each other, and the dots I try to capture of it's the people, and then they interact in this end by end grid, kind of like an autonomous life simulation. And up at the top, you kind of had the who's infected, the death rate. It's too many ums on this as I go through it to try to think about this. Sorry. You got the idea. There's these probability transitions, so it could be a Markov model. There's a lot of places this fits in, immediately relevant to COVID situation. It's out there. You don't even have to develop this one. What one of the people we had do, one of our faculty created and had this as an exercise for the students. So again, what's the difference? No exercise existed like this. We were going to create something, and we just tried to go after a social good problem. That's what level 2 is. Another one that's due to Mikey is the addiction assistance areas. So you can get this. It's a K. I started thinking of this. He does it as a priority Q1. It's an open data set again. It's where people are the highest percentage of addiction versus treatment centers. I started thinking, okay, it's a K nearest neighbor one. I've never tried that in my AI course. I got a general introduction AI course, so we don't call it machine learning. We got other. In fact, in our institution, for what it's worth, the data science degree is in a different department than the computer science department. It's just the way they did it, and or the EM algorithm. So you get the idea. Here's what I'm going to do: a play it by ear on timing that I think is going to work a little bit better for the group. I wanted to see how long the activities are going, but I was going to ask you to do your turn. Think of a level 2 one, but I'm going to skip over the next two to get to what I think the last one is, to get you right back, I think, where we just left each other. So what's level 3? Level 3 is now you take a real world social problem and you solve it, but as an exercise. Okay, this is simplified, and I'll show you kind of the difference. You can claim that first one's kind of this way, but here's an example of something that we do at Regis. This is in an ethical leadership computer science course. It's not quite a capstone course, but it's right there. It was meant to be at the end of after the students had some chance to understand what we've taught them. And we have students select a real world problem to solve. And it has to be real. They have to turn this into their faculty member. It just there was, we get a published paper somewhere on this. I can forward it to you guys if you need be. Goes a little more details, but again, it's conceptually it's not real deep in a certain sense, but we do reject it if they don't pick what we think is a computing for the social good problem. We give them a little bit of leeway. We've had students do trail maintenance because we're in Colorado. People love the mountains, and we would consider that definitely an appropriate problem. But we're talking things like climate change, refugee problems. We're trying to get them to think really big. Now, they don't have to implement solutions to it in this course. So I'm not going to, they do have to go through sort of a business case. It's got to be computing related. We try to get them to focus on, you're not going to solve this problem yourself. So how are you going to try to convince other people to buy them in? Where are you going to seek funding if you're in a nonprofit? We don't ignore, by the way, the commercial world. For what it's worth, this is one of those observations you probably all had it. I tell my students, money's not everything, but it's nice to have. And if you're in an organization, there used to be a huge fight on our campus whether you could work for the CIA. Right? Some faculty thought you work for the CIA, you get corrupted. I don't want to go with it. Mine is, I would like my students to work for the CIA because maybe they sit and say there's the social good, right? I'm not anti anybody. So, but if you think the CIA is not doing what we wanted to do, then get your students to infiltrate it and bend it towards the social good, right? That's the solution to the problem. The key here, and to give you this example, and this is what's going to distinguish level 3 and level 4. Our students are not working with an external entity. Okay. We did do some work in research on, in this course, for example, they do case studies, they do the traditional things you thought, but here's what we thought was a little innovative in this. This is their project. They own this. They're not looking at Zuckerberg's failure because he had a lousy computer science education, just like I did. All right, so I can give you opinions here for this one. Imagine if he studied for the social good, right? I'm not claiming what he does. His work, he claims he's trying to help humanity, right? But he never projected ahead, right? He admits this. What happened? Right? Well, what happened is you should have thought about this could happen, and that's what we're trying to. Yeah, exactly, right. Yeah, and I'm not saying every aspect of it. Again, here's another good perspective that I learned from my daughter. That your worst case scenario is you end up in a courtroom. Right? You want to think about this. By the way, for the law and the legal aspects, we do a lot of this stuff too. My understanding is try to make your students understand when they're in hot trouble, they're in a hole, and stop digging and go get a lawyer, right? They almost always have representation, right? But don't dig yourself out because you're not trained as lawyers, meaning computer science students, economics. So that's kind of what we're trying to do there. That is historically, we'll see a little bit tomorrow, the talk I have of history, the legal issues, patent, stuff like that, is traditionally been what's done. The other activity, so here's the 4. I put them all together just so you can see. It's just to try to give you a framework. Again, the first levels, it's easy to get in. We focus on problems. Level 4 is the hardest one to actually accomplish. And I can't remember who it was. I was speaking with somebody at university where they really carry this off. We have service learning projects. It's not that we don't, but I mean, they have a pipeline. It works in and out every semester, and they've got groups. And I went up and asked the faculty member, how did you do this? And it was what was given today. Slow incremental steps, start small, grow it. It took them 7 to 8 years to get to this point. And that's a lot of commitment. But here you've got students working on real world projects with a stakeholder. Okay, so and I know a lot of you do that already. I've seen tons of examples in the data science literature, but that's the way we did this classification early on. All right, one of the things I'm going to skip, here's the actual definition of the design pattern, just so you can see it, but I want to skip over this because I think we have a better activity. This was somewhat self-serving. What I wanted to come out of this group, and if we get back to this later, you have ideas, I was thinking, can we get design patterns out there to help people? All right, you're brand new to this. You say, I want to do social good. And this was one of those things, as opposed to go and read the literature of 30 years, can I just go down and say, look, if I look at this, I look at this, I look at that, I can come up with something. There's some research ideas out that repositories really don't work as well as we tend to think they work, but we can get back to that. So what I want to do here is look at something. I'll give the history tomorrow. So it's flipped a little bit because I wanted you guys working. It's the way the organizers and myself wanted you to get your work in today, not just blast at you. So, but one of the things that came out of the ITSE 2012 working group was CSG-Ed case studies. And just to give you an idea, it's not real complicated, but down the left-hand side are learning objectives, if you want, concepts out of the curriculum. Okay, came straight at that time. I think it was curriculum 2001 for CS. Cross, you have some example projects. So radioactive mice, we'll look at that a little bit in the next slide. At least I think I will. Interesting, right? This is the problem when you edit your slides, right? As you're like other people are talking. If not, I'll come back and tell you. The Red Cross one is the ambulance distribution disaster shelter. So now you're basically doing a shortest path. I normally do, I just told somebody this, but first note, I skipped to myself. I'm not an expert. I'm not pretending to be an expert, right? Like you're all. I've just studied some of this. I still do routing when it comes up, traveling salesperson, and I think a FedEx, UPS, because the students can connect to it. The better social good one might be routing an ambulance, and I've used that sometimes too. And it's a real problem. In Denver, it turned out they don't necessarily route on shortest path. They route on health insurance considerations. And that's another one that you don't want to make the news. And it did. It made the news and it blows up and it's a public disaster. Now, somebody made that decision. Okay. But again, you can get your students thinking about this. There's something in your own community. So I don't want you to make the think that like, oh, I'm just thinking these up. That one came straight out of the news. There was the design pattern we used. And again, the patient died too. So it's about the worst case scenario you can have. Okay, so here's skipping ahead. It was 2 slides ahead. The radioactive mice is just this idea of there's a lot of data out there. I can get it for you, but animals are showing up contaminated with radiation in certain places. Hanford nuclear site out in Washington State, the reactor that Fukushima that burnt melted down in Japan, and now. You start doing this interaction sort of mice one. And again, it's the same type of idea. What I'm trying to get at for this one now is what they did is they started doing categorization. So is it a student directed project or is it faculty led? What just popped in our last SIG-C conference, somebody asked, how do you do some of these things in a 700-person lecture hall? I don't know the answer. Okay, I got classes of 20. I can imagine recitation sessions, but now I've never seen this. Maybe somebody ought to, how do you get TAs involved in computing for the social good? How much scaffolding is the faculty providing? And I'm just, it doesn't have to be this framework. I'm just trying to give you something that was done before. Do they need external domain knowledge? Okay, this one's tricky too. Excuse me. Excuse me. I actually have a lung disease and sometimes it hits like asthma. Okay. So biology, now we're gonna make her famous, right? One of the problems is if you're in an early class or whatever, how much domain knowledge do they need, right? A lot of problems that are really cool, social for the good, biology, chemistry, physics, require a lot of domain knowledge, and we're all ripping at the curriculums. We don't necessarily always have enough time to do that. So that's what that was trying to get at. How much is it addressing the social good? You can always do. Well, I said I've never heard go back and redo an assignment for it. There's definitely out there. You can always ask students what's the impact. If anything, my intuition says it's one of the better things you can do. I just gave when the Zuckerberg example popped into my head, right? Of project, think ahead. You are going to implement software in the world. What's going to happen? And ACM Code of Ethics, ethical principle number 1, everybody is a stakeholder in computing. So there's no idea that you're just building this for your users. And I've been out there in the corporate world too, and I get it, but users, it has implications. Again, we're not telling the students what to do. We're getting them to think about this, right? You're going to deliver this thing that's going to change people's lives. And you had something in mind, that's fine. But did you think about the indirect? Okay, Terry Winograd, years ago, a famous AI researcher, right, of linguist. He's not a linguist, computer scientist, but he had this, right? We throw software out there and we can only hope that it achieves what we want it to achieve. But one of the things to do that I didn't hear him say, and I wish it's been a long time since I spoke with him, but ask him like, well, you can ask students to think what might go wrong. Coolness. Right. This is to try to get an engagement, right? Some of the we're doing this is you want this certain cool factor. You want the students to be engaged. This is a difficult thing. I'm bleeding in the mire a little bit, but we kind of know in general, male students like these gaming stuff. It's an absolute turnoff for the female students. But there's been some data that suggests then make the gaming about a social good thing, and you begin to bring them back in. So again, I was trying to tell you, I'm trying to stay upbeat and avoid the barrier, but there are definitely barriers, right? You've got to meeting students where they come from. You need a lot of privilege too to be able to do some of this stuff. So again, that was the reflection one. They did a categorization of what concepts, to me, that's the learning outcomes. They would then describe how are the implementation strategies going? What are multiple cats? Oh, by the way, where the cats came in is the mice, is you have robotic cats, right? It's if you go to the Russell Norvig book, this is essentially the vacuum cleaner environment. I have students, they give two cells. I have students extend it to multiple cells because I live on mining claims where we own the mineral rights. I have them actually reclaiming mines. That actually happens up there. And so they got to go in and they're making the environment safe. But this is that same idea. You're in this grid, you run around, the cat's collecting these mice. And Mikey said maybe killing them. But the question is, you don't want these mice out. They get into the food supply. But it's in some sense another simple level 1 type of activity that's been changed a little bit. And again, deliverables. So what I was thinking we can do is, now I got what their slide was going to. It assumes, and I wasn't sure I could make this assumption, that you know what the learning outcomes are across the data science curriculum. I know you probably know your own learning outcomes. So what I did real fast, and Carl's worked on this committee, so it's great work. Here's the knowledge areas in the data science curriculum that was done. This is that, I think it's an ACM curriculum. So help me again. I'm not the data science per se expert. These, of course, knowledge areas get broken down, the knowledge units get broken down into topics. It is available online, just ACM data science curriculum. But what I thought would be cool in this workshop then was to begin, kick it back to you guys, doing some work. We're at 5:35, so we can spend easily a good 20 minutes, 25 minutes if you're engaged, come back, report back to the group, gets us in about the right time. But to finish my sentence, out of that ITSE working group came these case studies that others then could use. Wouldn't it be cool if at this workshop was the start of case studies? I don't have any druthers that we get it done, but we start this community. I'll admit I'm a bit of a, I think of public places like inroads, right, for education. But wouldn't it be cool if this was the first step in starting a set of case studies that cover this curriculum? Right, in this workshop, I get there's other stuff out there, but we have the ability of several of us in the room to bring this forward into. I don't like publications today because they're so slow compared to bloggers, but we can get it out there. I'm most familiar with ACM Digital Library. I'm sure we can get it out into the digital library as a published group. And what are we doing? We're building this community. So I hope you feel my enthusiasm, right? Of what you, not me, I'm not doing any of this work. I'm just walking around, right? What you guys can create here today not only helps yourself, but you can help the generation of people getting into this new degree. I get it. You can find machine learning stuff back in 1959, AI, understand, but the people come into this new. And if I hadn't told you, I spent the first 2 or 3 years, for what it's worth, single data point, in designing curriculum. And then I discovered the 2001 ACM curriculum in the course I was teaching. And it was like, oh my God, isn't this the greatest thing in the world? Right now, anything I disagreed with, I ignored. It's fine. Anything that I really liked, then I agree with, right? I hate to say this. I use it as the Bible. Thank you, God. But you know, when it's appropriate, you can do this. So these case studies can go that way for any of us in this community. Okay. So again, if you want to switch up groups, that's fine, whatever you guys self-select. But the idea is to start getting at some definitive examples that maybe the whole community can use. Here was the structure that was just used by the ITSE group. But again, you don't have to do that. I'm trying to build community. I'm not trying to create these deliverables. But if we happen to create deliverable, right? My first AI joke I ever heard, right? We're using AI and it's like the goal is to get to the moon. This was Dr. Louis Steinberg at Rutgers University. So we want to get to the moon and we're climbing a palm tree. So don't look at it that way. Look at it as I like coconuts.
I would put a little bit of an extra little caveat twist on this as you think about this task for case studies. Having just participated a couple of weeks ago in case studies in a separate workshop on ethics case studies. So I'm going to tell you all, don't write any ethics case studies. There's other people that are already thinking and working on this. I want to push you to go the direction that sort of Rick had on his previous slide with thinking about things that you're not either knowledge or content that you either teach in your data science classes or your computer science classes or things like that. And think about what is a case study from a social good perspective that is going to address one or more learning outcomes that you're already trying to hit in your classes. That was it. That's all I wanted to add to that. I just wanted to push us away from the ethics, not because ethics aren't important, but because I don't want, there's other people focusing much more on teaching about ethics itself. Let's think about content. Let's think about content topics that are bringing in the social good perspective.
No. That was fantastic. Fantastic. If I use the word ethics, man, you guys can proverbial shoot me. Oh, okay. Yeah. I want to be careful because what you'll learn tomorrow is this is the big shift in the community that happened, right? Everything was ethics. And we're looking for social good. To coin a phrase, the opposite of not doing harm is not doing good. Okay, that's going to be an intentional. So yeah, no, but I think that exercise clarifies it a little. Thank you, Carl. You flipped it back, but here. Okay, everyone, if you can finish up. Okay, we're going to try to bring it back together. We've got a lot of time together to keep conversations going. So one thing that happened, a question came up, and it's something I'm not at all knowledgeable of or prepared to answer, but this is where community can help us. What happens if one of these CSG activities, these will be my words, triggers PTSD, mental health issues? I have not experienced it. Okay, what I've experienced, I told people, is more the political side, but I can manage that in a classroom. I mean, I'm not saying that the students aren't getting mad and frustrated and all that, but I can manage that. Where with mental health issues, beyond general stuff like we do IRB, was my thought of knowing where the counselors are and what the interventions are. But again, I'm going to say area I'm not too knowledgeable about. As we go forward, the reason I'm telling you right now is I don't want to lose this. This seems to be very, very important that we want to consider. I will certainly reach out to the community. I've been doing I've been doing this type of stuff for my whole life, but I only got connected in the community about 8 years ago. Now, to keep saying, don't apologize, don't apologize. But some of the people I'm dealing with, and you'll see their names tomorrow, have done this for 35 years. And I'm going to reach out to them to see whether they know anything. I don't think right at this moment I want to address it because it's the tangent off. However, if anybody knows anything about this and we want to bring this up, as future workshop, please. Thank you. And again, a great example that I'm first brought up in a different way, right? We want this community. There's people out there that have experienced things, people working on stuff. And again, I am, please don't do it. I'm avoided. This is one right back to, I make things very personal, as you learn, right back to my wife, who did a couple of rotations in mental illness. We have a mental illness in our, I know I am not qualified to do this type of thing. I know certain stuff, but we want to make sure the whole community is prepared. Please, we should do a microphone. So when I say like the community, I'm thinking I get that this is a diverse group in here from business faculty and biology. I tend to think of the computing community, the data science type community, who were faculties. I mean, the whole thing is to get us away from the silos that we live in. And I think my personal opinion, these are just all that's happening now, is here's one of these silos, right? As educators, we do, it's not that I've ever not had a seminar or this or that on mental illness, how to handle people in a classroom, but I'm specifically thinking of the CSG, right? I'm doing, I don't want to make light and joke of it, but radioactive mice, and then all of a sudden I have a student whose parents work in the nuclear industry, or I tend to make in the outside world fun of Texas because my wife's from Texas. But there's these triggering events. I've had training on military vets because we have a lot of stuff. But what I'm specifically thinking about, at least just for me, I never thought about the CSG-Ed activities themselves triggering because it hasn't happened to me. Now, maybe it's because my stuff's pretty simple. However, the example that we have given of COVID, I used COVID for Bayesian networks, Bayesian reasoning in the AI course, because I just think healthcare is a great way to do it. And COVID was real at that point. I didn't get feedback, but maybe the students just clammed up and I didn't realize it because we were in a virtual setting at that point. Anyway, it's something to consider. Since I got the podium, I'm going to say let's make it, not because it's not important, but let's make it tangential, right? We were on this activity, and I'll try to bring back. Now, I don't know if we want enough, we have enough time to get sort of towards 6:15, but let's bring it back. Anybody want to report? I mean, you did something that's just so interesting, so cool that you need to share it or want to share it with, and I would beg you to do so, right? I'm trying to manage time, as we all do, but any table. If not, I'm going to call on Carl because I don't know, right? Can you volunteer? Sure, please. Yeah, the faculty, right? You don't want the faculty to point to you. Yes, it's your turn. Please.
Sure. So we talked about the cases where we can actually bring some kind of data set into our classroom, for example, to have the student maybe using some classification algorithms or even some deep learning algorithms to make predictions or readiness assessment for transfer student or things like that. That will definitely help the student make better assessment on their readiness, on their academic performance, and also maybe their job market placement. But the problem here is we've run into some conversations and we feel like, how do we get the data? Right. And the data, of course, the best would be we have some real data. However, real data can be very sensitive because it could include student performance data and their demographic information, and also, for example, their I would say their financial situation, their family data and whatnot. So to get that data, we talk about using GAN, generative adversary, I think it's called generative adversary network, right? So can we use that tool to generate data from the real data, but still then we have to go through a whole bunch of other processes, procedures to get the original real data. And we also talk about maybe it's a good idea to have someone come to the school or come to the classroom to give student a FERPA training. And that could be actually a good component of this course that's also going to be a good learning process for the students. So we've talked about different kind of ideas, and we think, we don't really come up with a very tangible or concrete plan, but I think that we entertain different ideas, and we think that this could be, we could use that idea to actually, extend it into a more comprehensive project. So students actually get opportunity to get themselves trained in a multitude of aspects, I would say. Thank you.
Thanks for volunteering. 5 more minutes we got if somebody else wants to. Please, please.
Okay, so this is more following this format, okay? So the task name is Impact of ChatGPT Analysis. It's student directed, social good, coolness, reflection. Also learning the concept of positive and negative impact of using new technology. Implementation, of course, the students can get accounts and learn and put many different examples from many different domains. They can ask 10, 12, 15 different questions, and deliverable is like a list of positive and negative impacts, and they can compare their results.
It's our star students here. They followed the actual assignment. Yeah, good job. Sure. Yeah, please. Yeah, as keep reinforcing, this is your workshop, not we're just facilitating.
We didn't follow the directions. So I lead a capstone program at NDSU for computer science. So we have real world industry sponsored projects that the students solve senior year, kind of like the level 4 of your taxonomy. So what we started talking about, I'd love to bring social good to this in addition to the industry project. I just don't know how. And I don't know if it fits this exactly from a case study perspective, but maybe it's more of a pattern related thing. What are the patterns that we can use to bring those types of projects into the university environment? One thing we talked about was maybe like local nonprofits might be a source for this, right? Where they might have problems and we can go source those types of problems. What else is out there? I mean, I don't know. Does WHO, the federal programs, what are the other patterns that we could use to bring these types of projects in? And that's definitely one of the things I wanted to get out of this seminar, is try to think about how we can do those types of things. So if others you have interest in that, that would be more than happy to work with you on that.
Okay, so I think that gets us close enough to where we're ready for a break. Don't raise up because Carl's got some stuff to do. I thank you. I hope it's been helpful to begin to kick off and stimulate your thinking on how we can do this. There's no claim that you haven't already been doing it. Again, from a pure CSG-Ed perspective is we're just trying to grow community so that we have resources and people to talk to. So thank you.